Good morning all of you. Decoder. Decoders. What is decoders? Here, which is used at the receiver side. The name indicates that it is a circuit which decodes the information. For example, assume that a block diagram of decoder. Here, if n input means 2 power n outputs here. Decoder means there are n inputs and possible outputs are 2 power n outputs. So, I taken 2 inputs, 2 power 2 means 4 combination. I will consider this is y0, y1, y2, y3. This n number of input means 2 power n number of outputs. So, here if A, B 0, 0, 0, 1, 1, 0, 1, 1. So, we will go for an truth table A, B, Y3, Y2, Y1, Y0. Now, here A, B are 0, 0, 0, 1, 1, 0, 1, 1. Depending upon input, the output is selected. When 0, 0, Y1 line is selected. When 0, 1, Y1 is selected. When 1, 0, Y2 is selected. When both are 1, 1, Y3 is selected. That means we are giving high priority to that line. 0, 0, Y0, 0, 1, Y1 line, 1, 0, Y2, 1, 1, Y3. So, like this the decoder will works. This is nothing but the truth table. We can go for an expression of the decoder. I can write y0 is obtained when y0 is what? When a and b are 0, 0. That means we are considering 0 state as a bar complement term. Therefore, y0 is a bar and b bar. Next, y1 is what? A is 0, B is 1, that is A bar B. A bar B. Y2 is what? Y2 is A is 1, B is 0, that is A B bar. A B bar. Again Y3 is A is 1, B is 1, both are 1, that is A is 1, B is 1 means A dot B. Now, we are going to implement this with the help of the logic gates. So, first one I taken 2 inputs A and B. What is y0? A bar, B bar. So, apply this to a NOT gate, apply this to a NOT gate. We got A bar, we got B bar. Okay. So, first thing is what? A bar, B bar. So, apply this one, again this one to the A AND gate. This becomes y0. Next, what we require? Y1 is required, A bar B. So, consider this and consider this. Apply these two to the and AND gate. This is nothing but y1. That is nothing but the y1. Next is what? A B bar. We require A, we require B bar. Apply those two to the AND gate, that is y2. Okay. Next is what? Y3 is A B. This is A and this is B. Take these two to the AND gate. This is nothing but the y3. So, this is nothing but a logic diagram of decoder. Decoder operation with help of the block diagram, truth table and also a logic diagram. This is nothing but the decoder. Next topic is flip-flops. which is made up of logic gates and which are used to store a binary data, 1-bit binary data. Binary means you know that 0 or 1. We can store either 0 or 1 with the help of the flip-flop. The types of the flip-flops are, first one, D flip-flop, next T flip-flop, S R flip-flop, next is JK flip-flop. So these are the main 4 types of flip-flops: D flip-flop, T flip-flop, SR flip-flop, JK flip-flop. So first thing is D flip-flop, that is called as the data flip-flop or direct flip-flop. Type of D flip-flop, it has a clock signal, and for all the flip-flop, clock must and should we have to use the clock signal for the operation. By applying the clock signal only, it will start the operation, otherwise it don't start the operation. So clock is always 1 and the input is D, that is nothing but the data flip-flop. And here there are 2 outputs for the flip-flop. One is Q and one more is Q bar. That is complement of the Q, that is nothing but the Q bar. So D is the data and clock is always 1 for the operation, and D flip-flop. In this D flip-flop, only one input, that is D. So whatever the data present in D, that is appears at the output Q. For example, if D is equal to 0, the Q is also equal to 0. That means output follows the input, that is whatever the value of the D which follows to the output side, that is D is 0, Q is 0, but Q naught is complement of Q, that is complement of 0 is nothing but 1. Okay. Now let us consider that the other condition, D equal to 1. When D equal to 1, the Q becomes 1. Whatever the data present in the D which is appears at the output side. So when D equal to 1, Q is 1. What is Q bar? Complement of Q, that is 0. When D equal to 1, Q equal to 1 and Q bar equal to 0. Therefore, the output is equal to input with the help of the clock pulses by applying the clock pulses. This is nothing but the D flip-flop, data flip-flop. It's a simple one which has only one input and 2 outputs, Q and Q bar. The next thing is we're considering T flip-flop. Here also only one input and 2 outputs, and the clock is always present. Okay, input is T, another input is clock, T and clock. Outputs are Q and Q bar. The name indicates that T flip-flop means toggle flip-flop. Toggle flip-flop means whenever the clock signal is 1, that is if the input for the clock is 1, if clock is 1 and T equal to 1, then output will toggle. For example, so clock is equal to 1 and clock equal to 1 and T equal to 1. In this condition, then only output Q toggles. For example, let us consider that the previous value of the Q is 0, initial stage of the Q is 0, then T is 1 now, clock equal to 1. Then during this condition, output toggles, that is 0 changes to 1. Okay. If consider that initial condition is the Q value is 1, so let us consider that toggle input is 1 and clock is 1, then output toggle Q becomes 1 to 0. Like this, the output toggles with respect to clock and also the input T. Okay, this is nothing but the T flip-flop. Then we are going for SR flip-flop. Clock is always 1 for the flip-flop operation. S R, the output is Q and Q bar. So 2 input means how many combination? 2 power 2. Don't consider clock is also a combination of those 2 inputs, S and R. SR is different, clock is the continuous pulse which is used to start the operation clock. This is a different input and these 2 are different inputs. S, R, and clock is always there. Output is Q and Q bar. It is always 1. If it is not 1, then the operation will not start. That's why we should make clock is 1 to start the operation. SR 0 0 0 1 1 0 1 1. Okay. Now SR flip-flop is a different case because there are 2 inputs and we are concentrating on the operation of the SR flip-flop. We will consider the operation of the SR flip-flop with the help of the NAND gate latch. So here the 4 NAND gates, the names are 1, 2, 3, 4. So S and R are the 2 inputs for the SR flip-flop and clock is always equal to 1 for the operation. And the output of this we will consider that as S bar and output of this is considered as R bar. So here the flip-flops 3 and 4, one of the inputs are the output. Q is connected to the 4th flip-flop input and Q bar is connected to input of the 3rd flip-flop. This is the configuration for SR flip-flop. That is the logic diagram. Logic diagram of the SR flip-flop. The operation of the SR flip-flop, S equal to 0, R equal to 0. So if S equal to 0 and R equal to 0, now I am considering that for the operation initially Q is 0, Q is 0 and Q bar is 1. So this is 0 and this is 0, first condition, and clock is 1. This S is 0 and clock is 1, therefore this is 0 and this is 1. What happens? For the NAND gate output, for output is 0 for 1 1 condition for the NAND gate, other than that output is 1 always NAND. When this is 0 and 1, the S bar is 1. Here R is 0 and clock is 1, the output of the NAND gate 1 and 2 are 1 1 respectively. This is 1 and we are connected the another input for the flip-flop 3 as Q bar as 1 1. Therefore S bar is 1 and Q bar is 1 now. When both are 1 1, output is what? Output is 0. Q equal to 0. Alright. Similarly, we are considering initially Q is 0 and that is applied to here. The inputs are NAND gate 4 is 0 and 1, the output equal to Q bar equal to 1. So we are initially consider that Q is 0 and Q bar is 1, so the outputs are obtained as same 0 and 1, so there is no changes in the output condition. Okay, so therefore for this 0 0 condition, no change, or we can consider previous stage as it is. So we will go for another condition, that is considering Q as 1 and Q bar as 0. 0 1 output is 1, S bar is 1. When 1 0, R bar is 1. Okay. So here we are considering that the flip-flop 3 another input is Q bar. Q bar we are considering as 0. 0 is applied here. So therefore 0 and 1 output is Q is 1. Q is 1. Therefore here 1. So R bar is 1 and this one. This input is 1. This is 1 and this is 1. Output for the NAND gate is 0. Observe here. The previous condition is 1 0. The present condition is 1 0. Therefore we can say that the output won't change. No change in the previous output. The output remains constant, same, won't change. We'll go for next condition 0 and 1. So here S equal to 0 and R equal to 1. That is the condition next one, but clock is always 1. Now this is 0 and this is 1. 0 and 1, output S bar is 1. Here this is 1 and this is 1. So NAND gate output R bar is 0. There is flip flop for SR flip flop. The NAND gate 1 output is 1. NAND gate 2 output is 0. Let us consider that Q is 1 and Q bar is 0. Now when S equal to 0, R equal to 1. So clock is 1. Let us consider that 0 and 1. The NAND gate output is S naught, S bar, that is nothing but the 1. Next is when R equal to 1 and clock equal to 1, both are 1 1. The NAND gate 2 output is 0. That is R bar is 0 and S bar is 1. So let us consider that this is the input 0 for the NAND gate 1. So without considering the other input, so the output is 1 always, because for the NAND gate any one of the input is 0, the output is 1 always. So let us consider that the NAND gate 4 output is 1. NAND gate 4 output is 1. This 1 is connected here, so this becomes what? 1. When this is 1 and this is 1, NAND gate output is 0. Now observe here. So S equal to 0, R equal to 1, the output Q is 0 and Q bar is 1. That means we can say that the SR flip flop is also called as set and reset flip flop. When R equal to 1 means reset equal to 1, so the output Q is 0, that means it is reset. So that is Q equal to 0 and Q bar is 1. Next, we will go for another condition, S equal to 1, R equal to 0. S equal to 1, R equal to 0. Now we will go for analysis. Here both are 1 1 means the input for the NAND gate 1, S is 1, clock is 1, the S bar is 0. Therefore here R equal to 0 and clock equal to 1, any one of the input is 0 for the NAND gate means output is always 1. So this is 1 always, the output is 1. Now we will go for this condition. So one of the input for the NAND gate 3 is 0. So without considering the other input, we can say that the output is 1 always, because any one of the input is 0 for the NAND gate, output is 1 always. Okay, always output is 1. So this becomes 1. So this is 1 means which is connected to the NAND gate 4 input. So this is 1 and this is 1. Both are 1 1 means what? The NAND gate output is 0. When S equal to 1, R equal to 0, output is set. Q equal to 1 means output is set. Therefore, S equal to 1, R equal to 0, output is 1, Q bar is 0. Set. So when R equal to 1, output is reset. When S equal to 1, output is set. Q is set. Next is, we are going for another condition, S equal to 1, R equal to 1. We are going to analyze that. Now let us consider that both are 1 1. This for the NAND gate 1 inputs are what? 1 1. Output is what? Both the inputs are 1 means output is 0. Output is 0 from the NAND gate 1. Next, when both the inputs for the NAND gate 2 is also 1 1, so output is also 0. Therefore, the NAND gate 1 and NAND gate 2 outputs are 0. Observe here. So without considering the other input, the inputs for the NAND gate 3 and NAND gate 4 are what? 0 0. Hence we can say that this also 1 and this also 1. But this is not valid point. This is not the valid condition, because whatever the situation, the Q and Q bar is not the same. Q is 1 means Q bar is complement, and Q is 0 means Q bar is 1, its complement. That means both are 1 1 condition is not at all possible. This is called as indeterminate form or not defined state. So this is the problem in SR flip-flop. That is, when both are 1 1, Q is also 1, Q bar is also 1. This is the indeterminate state. It is not at all possible in the real-time application. That is the drawback present in the SR flip-flop. To overcome this problem, we are going for another type of flip-flop, that is nothing but the JK flip-flop. It's the combination of SR with some circuitry, so that we are going to overcome the last condition, both are 1 1, that is Q and Q bar is 1 1. So this is the not defined state we have to eliminate. That's why we are going for the JK flip-flop. So this is the JK flip-flop. JK flip-flop is nothing but the extension version of the SR flip-flop. To overcome the last indeterminate or not defined state, we are going to consider the JK flip-flop. This is J and this is K. We are considering this is the AND gate 1, this is the AND gate 2. Here the AND gates 1 and 2 has one of the inputs is J and K, and other inputs are Q bar and Q for the logic gate AND gate 1 and 2 respectively. AND gate 1 has the two inputs, one is from J and another from the Q bar. This is nothing but the Q bar. And logic gate and logic gate 2 has one of the input from the K and other input from the Q. Okay. So this is J and K and this is Q bar and Q. Therefore, the output of 1 is JQ bar and output of 2 is nothing but the K into Q, that is AND operation. And remaining thing is same with respect to SR flip-flop. Let us consider that J is 0 and K is 0, and we are considering that for initial state Q is 0 and Q bar is 1 for analysis. So this J is 0 and K is also 0, both are 0. Here Q bar is 1 and this becomes 1, and Q is 0, this becomes 0. Now the AND gate 1 output is 1 with 0 is 0, and K is 0 and Q is 0, both are 0, output is also 0. Now S equal to 0 and R is also equal to 0. When both S equal to 0 and R equal to 0, the previous condition is studied that in SR flip-flop both are 0 0, the output remains same, won't change, that is Q is also 0 and Q bar is also 1. So the present value is same as the previous value. The answer won't change. This is what? No change. Next, we will go for another condition. J is 0 and K is 1. Now let us consider that the operation Q is for Q 0 and this is 1 for. Now J is 0 and K is 1. Now we are considering Q bar is 1, that is equal to 1, and Q equal to 0, this is 0. So for the logic gate AND 1, which has the inputs are 1 with 0, output is 0. So your 1 and Q is 0 and K is 1, 0. Now S equal to 0, that is S is nothing but J in Q bar, that is we obtained as 0, S equal to 0, and this value also equal to 0, therefore R equal to 0. When both are 0 0, output remains same, that is Q equal to 0 and Q bar is 1. So the previous state is follows. For example, the next condition is when J is 1, K is 0. Let us consider that Q and Q bar as 0 1 as it is. So Q bar is 1, J is 1 means this becomes 1, therefore S equal to 1. When K is 0 and Q is also 0, both are 0 means output is 0. So when S is 1 and R is 0 for the SR flip-flop, the output is 1 and Q bar is 0. Therefore, when 1 0 condition, the output is set, Q is set and Q bar is 0. The next condition is very important thing. You have to concentrate on that, how it will overcome the 1-1 condition. Let us consider that J and K are both are 1-1. Let us consider Q and Q bar is 0 and 1. Q bar is 1 and Q is 0. For the AND gate 1, both the inputs are 1-1. So therefore, AND gate output 1 is 1. Next, here K is 1 and Q is 0. When 1, 0, the output is what? 0 for the AND gate. Now, this becomes 1 and R becomes 0. Okay. So, when S equal to 1, R equal to 0, what happens? So, when S equal to 1 means the Q becomes 1 and Q bar becomes 0. Now, the previous state output is 0, the present state output is 1. And the previous state of Q bar is 1, the present state is 0. That means output toggles. We can go for another condition, that is considering Q is 1 and Q bar is 0. Observe here, when both J and K are 1, Q bar is 0 and Q is 1. Q is 1 means, so here these two inputs are 1-1 means output of the AND gate 2 is 1. Therefore, R equal to 1. Next, one input for the AND gate 1 is 0 and other input for the AND gate 1 is 1. Then what happens? This one, it becomes 0. Now, S equal to 0 and R equal to 1. Therefore, this works as a reset flip-flop. That means output becomes S equal to 0 means output, R equal to 1 means this becomes 0 and this becomes 1. Now observe here, the previous state output is 1, the present state is 0. The previous state is 0, the present state is 1. Therefore, output toggles. Therefore, here for 1-1 condition, output toggles. But it overcomes the indeterminate or not defined condition with the help of the JK flip-flop. That is data flip-flop, toggle flip-flop, set and reset SR flip-flop, and advanced version of the SR flip-flop is nothing but the JK flip-flop. These are the 4 important types of flip-flops. The next thing is shift registers. Before going to shift register, we'll see what is registers. Register is a logic circuit which holds or store a data word that is more than 1 bit. Either it's a 8 bit or a 16 bit, etc. So it will store more than 1 bit of data. Shift register. The name indicates that shift. So the register value is shifted either right side or left side depending upon the application, hence the name called as the shift register. There are 2 types of shift register. One is synchronous shift register and one more is asynchronous shift registers. Here synchronous means we are applying a common clock to all the logic circuits, all the blocks. Whereas asynchronous means we are connected only clock to the one module, then output of that module is connected to a clock of the next one. This process is repeated till the end of the operation. So your shift register means, for example, consider that a data. So assume that this is the D0, this is the D1 and this is D2 and this is the D3. So clock is applied for the operation. This is the clock, this is the data in and this is the data out in left shift operation. That means whenever you are applying the clock, the data shifted by one position left, because we are considering the left shift. In left shift, so the D0 moves one position left to the D1, again D1 to D2, D2 to D3 position, but D3 is going out of the shift register. Therefore, we can call that the next data in is coming here and the last data D3 is going out in the left shift operation. Depending upon the number of clock pulses you applied, shifting of the data. How many shift you require, that much of clock pulses you should apply. The next thing is shifting towards the right side. So in right shift operation, by applying the clock pulse to the shift register, so the data is moving from left to the right side. That means D0 is going towards D1 when D in data entering to the D0 by one position movement of the data. D0 to here, D1 to here, and D2 to here, and D2 to D3 here, and D4 is going out of the shift register. This is nothing but serial data in and right shift or left shift. Okay.